This is the screencast for section 5.5, example 4. Some applications of the law of sines property using non-right triangles. The setup and work for these two problems, the example and the now try problem, are very much the same as examples 1, 2. So I've eliminated going through all the work, and we're really just focusing on the setup in these two problems. So let's work on that. Forest Ranger Chris Johnson at Ranger Station A sights a fire in the direction 32 degrees east of north. So Ranger Station A, I don't know, maybe here, we'll call that Ranger Station A. North is here. 32 degrees east of north is going to be a 32-degree angle east. So maybe something like this. Ranger Rick Thorpe, okay, at Ranger Station B, maybe that's here, 10 miles due east. Oh, okay, 10 miles due east. So I do know, oh, okay, so I do know exactly where that is in relationship to Station A. Due east is this, oh, so I was right. So here's 10 miles due east. Sights the same fire, same exact fire, on a line 48 degrees west of north. So if this is north, 48 degrees west of north is going to be this way, just at a little bit steeper angle than the 32 degrees. So here's 48 degrees. Somewhere these two are going to have to meet, and we're going to get a fire up there because they both spotted the same exact fire. As I said before, I have already done this problem, and we're just worried about the setup. So I know that I have an angle side angle situation. I can take 180 degrees, subtract those two angles, find this third angle, and then I'd be able to set up the law of sines to solve this entire triangle. And I will show you that work right here. So here's Ranger Station A, Ranger Station B, the 32 degrees, the 48 degrees, which means this, instead of a 90-degree angle, would be 42. 90 minus the 48 is 42. 90 minus the 32 is 58. So now 180 minus 58 minus 42 is 80 degrees. Now I'm able to set up the entire law of sine, or excuse me, the law of sines to solve the entire triangle. And I get that Ranger, who's Ranger A? Chris Johnson is 6.79 miles away, and Ranger Rick Thorpe is 8.61 miles away. The now try problem number 45 already has a picture set up, but we can talk about that just so we can learn how to set this up as if there weren't a picture there. There are two lighthouses, A and B, and they're known to be exactly 20 miles apart on a north-south line. So they're obviously going to be on land 20 miles apart. On a north-south line, so they are directly north and south of each other. A ship's captain at S, so somewhere out here, measures ASB, this angle, to be 33 degrees. A radio operator at B, the other lighthouse, measures ABS to be 52 degrees. Find the distance from the ship to the lighthouse. As I mentioned before, the setup of this is very much the same. We have an angle and its opposite side. We have angle S and its opposite side, so therefore we would be able to solve the rest of the triangle using law of sines, which I have done here. And let's see, I set up this proportion, the sine of 33 over 20 equals the sine of 52 over B, to find out the distance between lighthouse A and the ship. Then I set up the sine of 33 over 20, the initial ratio I know, with the sine of 95 degrees, which I got from taking 180 minus the 33 minus the 52 to find out what angle SAB was. And then I was able to cross multiply and find out that the lighthouse and the ship are 36.58 miles apart.